Continuation with our lecture with analysis of statically determinate beams. We have this second example. So I've already posted the example number 1 discussed from the other class yesterday, and here's the second example. So we have here a cantilever beam with a varying load from point A to point B of 4 meters, 0 to 8 kilonewton per meter, and a uniformly distributed load from point B to point C of 6 meters at 5 kilonewton per meter, and lastly, a concentrated dead load at point C or at the end of the cantilever beam of 10 kilonewton. The requirement now is for us to draw the shear and moment diagram of the given beam structure and determine the maximum shear and moment as well as the point of inflection if there is a point of inflection later on our shear and moment diagram. Okay, so first things first, ano ang kailangan nating isolve muna bago tayo mag-plot ng ating shear and moment diagram? Anyone?
Sir, yung degree of determinacy po.
So of course, we need first to determine if this particular example is now indeed falls under a statically determinate beam. So how do we determine the degree of determinacy of a beam component? So the number of reaction minus 3 times the number of parts. So how many reaction can we identify here? So of course, there is now vertical reaction at point A, and a horizontal reaction, and lastly, of course, the bending moment. We will then verify the bending moment if it is clockwise or counterclockwise. But for now, we'll have to assume it as counterclockwise moment at A. Okay? So we have there 3 reactions. How many parts or how many beam section do we have? So we have only one part for this particular cantilever beam. So again, that is 3 times 1 gives us 0 or a 0 degree of determinacy. Basically, this is now a determinate beam. So we could then apply our basic or conventional method in solving statically determinate structures. Summation moment about a point, and set the system in equilibrium by summation moment, summation forces horizontal, and summation forces of vertical. Okay? So how are we going to next? Ano susunod after determining the degree of determinacy? Ano susunod? So remember this, when you are solving a statically determinate structure or statically indeterminate structure, the difference between those two is that if it is a statically determinate structure, you can then immediately proceed in solving the reactions at the given supports. But if it is a statically indeterminate structure, you must then first solve the maximum deflection or the deformation happened within the span of the beam or within the structure. So, deflection muna bago reaction pag statically indeterminate. Pag statically determinate, we can then immediately proceed on to solving the reactions at the given support. So, how do we first solve the reactions here? Ano na yung unahin natin? Yung pinakamadali na muna. Summation forces horizontal. As you can see here, there are no applied axial forces on our given example. Wala tayong external axial force. So, kung walang axial force or horizontal force, basically, we have now AH equal to 0. As simple as that, no? Now, anong pwede nating susunod na gagawin? Summation forces vertical. Kasi wala namang ibang support doon sa other end ng ating cantilever beam maliban lang doon sa fixed support. So, vertical applied loads also. Basically, that is already solvable by summation forces vertical equal to 0, upward forces positive. What are the applied load? We have the varying load and the We have the varying load, and the uniform load, as well as the concentrated load. So computing the resultant of the varying load, that is basically a triangle, so that is 1/2 base times height, 8 kilonewton per meter times the base of 4 meters. Plus, lahat ay downward, so minus the uniformly distributed load, 5 kilonewton per meter at a span of 6 meters. So parang ano lang yan, rectangle, base times height. Then we have the concentrated load also directed downward of 10 kilonewton. Maliban na lang doon sa ating reaction at the fixed support vertical, AV, upward. Equal now to 0 to put the system in equilibrium. Simplify, negative 1/2 of 8, ba? 1/2 of 8 kilonewton per meter times 6, times 4, minus 5 times 6, minus 10. Transpose to the other side, AV is equal now to positive 56 kilonewton. So, yan na ngayon yung ating reaction vertical at the hinge support. Ano na lang ang kailangan nating isolve? We need now to solve. Next one is our moment. So, summation moment about A to solve moment A. Okay? About A, positive. So, how do we moment those forces at point A? Unahin natin si MA. MA or summation moment A is assumed to be counterclockwise. So, if it is counterclockwise, that is now equal to negative MA. Kasi yan yung unknown natin. Moment of all forces about point A. Yung pinakamadali muna. Unahin natin yung ating concentrated load. Concentrated load, ano si concentrated load? Clockwise, counterclockwise towards point A. At anong moment arm distance? So this is now clockwise about point A, 10 meter moment arm distance. So clockwise, positive, 10 kilonewton moment arm distance of 10 meters. Nababasa po ba kahit papaano? Nababasa naman?
Yes, sir.
So with that, 10 kilonewton times 10 meters, anong susunod? We have the uniform load. Hanapin natin yung resultant ni uniform load. Pag rectangle, laging nasa gitna yung ating resultant. So resultant ni uniform load, that is basically base times height. So base times height times half plus 4 meters. 1/2 of 6 meters. Okay? Plus 4 meters for your total moment arm distance. The resultant of the uniformly distributed load, clockwise din yan. So positive 10 kilonewton per meter times the base of 6 meters. The moment arm distance of the resultant of your uniform load towards point A is half of its span of application plus the remaining distance. So 6 over 2 plus 4 is what? 7 meters. Ilagay na lang natin. 6 over 2 plus 4 meters. And next one will be your varying load. With your varying load, the location of your resultant is 2/3 from the point of zero slope and 1/3 to the maximum point. So we have 2/3 of 4 meters, and this one is 1/3 of 4 meters. Okay? So how do we solve for the resultant of the varying load? Basically, that is a triangle. So area of a triangle, 1/2 base times height towards point A. Again, that is clockwise. So positive 1/2 of 8 kilonewton per meter times base of 4 meters times the moment arm distance, which is 2/3 of 4 meters towards point A. Equal now to 0 to put the system in equilibrium. Ulitin natin. Ito yung ating concentrated load. Ito yung ating uniformly distributed load, moment about point A. And ito naman yung ating varying load, moment about point A. Okay? Then, simplify, transpose to the other side, divide both sides by negative sign. Kaya na mag-simplify, 10 times 10 plus 10 times 6 times 3, 4, 7. Tama ba? 3 plus 4, 7 plus 1 half of 8 times 4 times 2/3 of 4 meters. That's supposed to be 2/3. Okay? Tama na ba? 10 times 10, 6, 7, 1 half of 8, 4, 2/3, 4. Gives us 562.67 transpose to the other side, negative, divide both sides by -1, gives us positive moment. Ibig sabihin, tama yung ating assumption with MA, which is counterclockwise, to resist the moment caused by the applied load. So that is 562.667 kilonewton meter. So this will now serve as our final answer for the moment or the reaction bending moment about point A. So we are now prepared to draw our shear and moment diagram, identify the maximum shear and the maximum moment. There is another type of diagram that you need to include here, which is your normal diagram. Normal diagram represents the actual force applied on our beam. Okay, actual force or the horizontal forces. But most of the time, actual forces are then applied to a frame structure. So if our horizontal force here is equal to 0, the normal force is simply equal to 0, or a simple straight line as its representation of diagram. So yan na yung ating normal diagram, also in kilonewton. So how about the shear diagram? We can now draw the shear diagram. So for our shear diagram, unit is in kilonewton, starting always at 0. Remember, we can always start at 0 and must always end at a 0. Okay, at point A, we have a fixed support, and we have recently identified that at the fixed support, there is an equivalent reaction upward of 56 kilonewton AV. So, i-plot natin si 56 kilonewton. Upward. So, upward, 56. Exaggerated yung figure, so kayo na lang po mag-scale later on sa sarili ninyong drawing. So, we have positive 56 kilonewton. So, if that is positive 56 kilonewton, then the remaining applied loads are all downward, directed downward. So, isusubtract lang natin lahat yan. Okay? So, we have here a varying load. 56 minus the area of the varying load. Nakalimutan ko. The varying load is on the first degree of a slope. 0 degree yung uniform, then wala na yung concentrated. Kung first degree yung ating load, then our graph should then be on the second degree of a curve. So, kung yan ay increasing varying load from 0, an increasing varying load, our curve will be opening downward. If it is a decreasing varying load, our curve will be opening upward. Okay, a parabolic curve will be opening upward. But this figure or this example has a varying load, has an increasing varying load. So, ang magiging curve natin will be opening downward. So, 56 kilonewton minus the area of the varying load is 1/2 of 8 times 4. That is positive 40. So, magiging curve. So, this is now positive 40 kilonewton. Nakuha po kung saan nakuha ang 40 kilonewton. Naintindihan kung paano nakuha si 40?
Yes, sir.
Then, if that is 40 kilonewton, meron pa tayong uniform load na 6 meters, also directed downward. So, 40 minus the area of the uniformly distributed load, which is 5 kilonewton per meter times the span of 6 meters. That is equal to 10 kilonewton. 0 degrees. So, susunod is just a simple inclined line. Yan. Then, 40 minus 5 times 6. That is positive 10 kilonewton. Sir, we did not end up at 0. Papaano nga yan? Tama na ba yan? Yan na ba yung huli ng ating solution for shear diagram? Or hindi pa? Hello? May susunod pa ba? So, we forgot the concentrated load of 10 kilonewton also directed downward. So, we end at 10. Subtract natin si concentrated na 10. We have now end up at 0. Meaning, the reaction that we have computed is indeed correct. Okay? So, tama yung ating reaction na na-compute. So, eto na ngayon yung ating shear diagram for this cantilever beam. Okay. So, how do we now compute the, or draw our moment diagram? Paano naman yung moment diagram? Moment diagram, kilonewton meter. Okay? Pwede na nating sagutan yung requirement. The maximum shear. What is now the maximum shear on our example? Ano ang maximum shear? Anong maximum shear? I know. Hello?
Yung 562 po, sir.
Yung ating 56 kilonewton. But that is already given, no? Most of the time, kasi when we are designing cantilever beams, most of the strain and stresses are now experienced at the fixed support of our cantilever beam. So, we mainly focus our design reinforcement or connection joints on our fixed support. So, how do we strengthen that fixed support or strengthen the anchorage of our cantilever beam with its fixed support, no? Next up is for us to solve our moment diagram. So notice here that this part of our diagram is already on the second degree of the curve, and this is also on the first degree. This diagram, we can simply solve this. We can simply solve this diagram by trapezoid, no? Pwedeng-pwede nating isolve dyan by area of a trapezoid. But how about this diagram? So how about this diagram? That is now a parabolic figure with a spandrel. So we can dissect this or assume this section to be a whole rectangular section. Then subtract the spandrel section over here to solve the area of this part. No? How are we going to do that? Dissect ko na lang muna. Labas natin yung figure. Okay. That is 56 and that is 40. Now, if we're going to assume this section as a rectangular section of the same dimensions, and that is 4 meters, this is 56 kilonewton and also 56. We will then have this section as a spandrel, no? So, ano yung difference ng section na yan? That is 56 minus 40 or simply 16. So, how do we compute area of a spandrel? This is in the second degree curve. Area of a spandrel is simply 1 over the degree of the curve plus 1 times base times height. Okay? So remember that the curve is on the second degree, so that is now 1 over 2 plus 1. 1/3 base is 4 meters at the height of 16. Okay? The height of 16. The area of the spandrel now is 1/3 of 4 times 16, which is 21.333. Then the area of the rectangle is 56 times 4 meters. So that is 224. So we can then compute the area of this section by subtracting the area of the spandrel with the area of the rectangular section. 224 minus 21.333. That is 202.667. Okay? Yan na yung area niyan. But remember that at point A, we still have the moment A, which is counterclockwise. If it is counterclockwise, anong gagawin? That is negative. Starting at 0, counterclockwise. That is moment A, 562.667 kilonewton meter. Okay? Then if that is negative 562.667 plus, ano yun? Nandito siya sa positive quadrant. Ito yung negative. So, plus the area of this section. Okay? So, the area of that section, which we have solved as 202.667, that is 562.667 plus 202.667 gives us, Tama ba? 562 negative 562.667 plus 202.667, which is 360. Yan. Okay? That is now negative 360 kilonewton. Okay? Kilonewton meter. And lastly, trapezoid. Subtract lang i-add lang natin sa 360 si trapezoid. Tama ba? Yeah. answer plus the area of the trapezoid. That is 40 plus 10 over 6 times, over 2 times 6. Tama ba yung aking na-compute? Tama naman yun. Area of a rectangle. 16. 1/3. 4 times 16. 21.333. 56 times 4 minus answer 202.667. That is negative 562.667 plus the area 202.667, 360. Then plus 40 plus 10 over 6 times over 2 times 6. Bakit nga 210? May mali sa ating example. Wait lang. May answer na yan eh. Nandito. There's something wrong. 10 times 10 plus 10 times 6 times 7. 7 plus 1/2 of 8 times 4 times 2/3 of 4. Wait lang. That is 8 times 4, 3, 7. Hindi nyo naman sinasabi. Nagkamali pala ako dito eh. Ano yan? That is 5. Ay na. Hindi naman kayo nagsasabi. Dire-diretso lang. So, mali na tong moment A. So, that is 10 times 10 plus 5 times 6 times 7 plus 1/2 of 8 times 4, 2/3 times 2/3 of 4. Ayun, 352. Moment A is 352.667 kilonewton meter. So that is anong 3? Ayun. 6/2 centroid nung ating resultant. Rectangle. Anong centroid ng rectangle? On center. So, center ng 6 meters is 3. plus yung moment arm na 4. So, bali 7 meters. So, hindi mo naman pwedeng i-moment yan as a uniform load. So, kunin natin yung resultant ng uniform load by multiplying the load times the base. 5 times 6 times 5 times 6 is 30 to get the resultant. And the resultant of a uniform load is located on its center span. Center span is 6 meters divided by 2, 3. Plus 4 para sa moment arm distance towards point A. Kaya 7. So that is 352.667 plus negative 352.667 plus 202.667. Ayun. Negative 150 kilonewton meter. Then, computing the area of our trapezoid. Area of the trapezoid, 40 plus 10 over 2 times 6. So, that is negative 150 plus, dahil nasa positive quadrant yung ating trapezoid, 1/2, 40 plus 10 times 6. That is basically equal now to 0. Also on the first degree, therefore, this will be on a curve. Ayun. So, it indeed ends up at 0. So, eto na ngayon yung ating moment diagram. These are now in kilonewton meter. This is in kilonewton. So we can then solve the final question from our requirement, which is now the maximum moment. The maximum moment, ano ang maximum moment? Maximum moment is simply located also on the hinge support, which is 352.667 kilonewton meter. So, yan na yung ating final answer. Now, there is another one question here. Where is now the point of inflection? Ano ibig sabihin ng point of inflection? The point within the span of our cantilever beam where the moment is equal to 0. Sir, 0 yung point A at point C. Hindi po yun ang ibig sabihin ng point of inflection. Point of inflection is most likely the point within the span of the beam dictates the maximum deflection, where probably the maximum deflection will occur or will cause the maximum deflection. So, the point of inflection, walang point of inflection dito dahil walang moment equal to 0 along the span of the beam. But, given that it is now a cantilever beam, most of the deflection of our beam will now be located at the free end of our cantilever beam. So later on, if you're going to design a cantilever floor slab, ganito po yung magiging reference ninyo. Ano yung allotment deflection ng free end ng ating cantilever floor slab for us to design properly the anchorage of our floor slab towards our floor beams or anchoring beams and so forth and so long. Maximum deflection to sustain safety of our cantilever structure. Ayan lang naman po yan. Okay? Naintindihan po. Hello?
Yes, sir.
Okay. So, yan lang naman ang ating example for this cantilever beam. Then, we can always check our answer with this figure. Actually, na-plot na siya. If you're going to plot your figure in a much more accurate scale drawing, ganito po magiging itsura niya. So, ito yung ating shear diagram. Ito yung ating shear diagram, which is exactly just the same from our figure here. And this is our moment diagram. Parehas na parehas, no? 352.67, 150, then 0. Okay? And as expected, the probable or the expected deflection of our beam will move on this manner. So, ganito yung magiging deflection ng ating cantilever beam. Then, you'll have to identify that particular deflection later on to set and design the dimension of our cantilever. Okay? So, dalawa ba sa taas? Kung ganyan yung deflection ng ating beam, most of the time, we will add more reinforcement on the top section. Okay? Kung reinforced concrete. Pero kung steel, you need to reinforce an anchorage dun sa ilalim. Lalagyan natin dyan ng frame. Dadagdagan natin dito to exert or reduce the effect of strain to our fixed support. Or you may add cable dun sa taas. Lagyan natin ng cable, hinge, anchored to the second floor, then anchored here. So, combination of beam and truss analysis. So, that is our example for cantilever beam, shear and moment diagram for statically determinate beams. The other example was discussed yesterday from the other class. Ito naman yung sa kanila. Mas marami. No? Might as well try to solve. If you come up with the same diagram, try to solve this figure and tignan ninyo kung parehas yung mailalabas ninyong figure. Ganon din dito sa pangalawang example. Okay? So, paano yung sa varying load? Baka hindi nyo pa na-gets yung sa varying load. Sa varying load, if the varying load is decreasing, just like this one, so, zero slope to a valued slope. The shear diagram should then open upward. Okay. Tama ba? Yes. Okay. Should then open upward. Okay. This is first degree. That should be on the second degree for the shear diagram. Then for the moment diagram, the diagram should then open downward, which is now in the third degree. Computing the area, that is 1 over the degree plus 1 base times height. Computing the area, that is 2/3 or 2 over n plus 1 times base times height. But if the varying load is increasing, just like this one, the curve now should open, should open downward. Okay, this is on the first degree. This should be on the second degree. Then compute the area of a rectangle minus the area of a spandrel. Then the next figure should then be tawag na dito, opening upward. Opening downward, which is on the third degree. Ganun ulit. Computing the area is equal to area of the rectangle minus area of the spandrel. But the area of the spandrel this time is now 1 over the degree plus 1 base times height. Pero yung N, that is already 3 degrees. Okay? Yan lang naman po. So later on, if you will encounter a shear and moment diagram on beams, mamaya meron tayong problem na ganito. Hinge, roller. Tapos, dahil sa dista si sir, lalagyan ko ng uniformly distributed load dito sa baba. Directed upward. Then, lagyan natin ng concentrated dyan. Tapos, lagyan ko dito ng varying. Then, lagyan ko dito ng frame section na merong axial force. Kung merong axial force sa member na yan, anong gagawin? We need to convert that into a moment. So, how are we going to convert that into a moment? That is your force times height. So, F times H, gagawin natin siyang moment, which is M equal to FH. Then, ito yung force, another force, and another force. Then, lagyan pa natin ng konting varying dyan para mas masaya. Though this setup of loading a particular structural beam is impossible. Hindi po totoo yan. It's just for the sake of example and for the sake of challenge, no? Pero most of the time, yung ganyang upward force are now part of uplift design for aircraft engineering. For aircraft analysis, we do consider uplift force just like this one. How does an uplift force cause the takeoff of a particular aircraft, no? Question. Question po.
Answer.
May question? Hello? May question? Siguradong walang question. So on your own, before you take the quiz, probably your quiz will be on March 24 to 30. Di ko pa sure yung exact date. Pero pagsabayin ko na yung problem para sa beams at saka sa frames para isahang quiz na lang kayo sa midterms. Tapos ang gagawin nyo na lang yung assignments. Practice on this example problem. No? Bigyan ko kayo ng pagpapraktisan. Of course, determinate beams pa rin. We have hinge here and another roller here. Tapos, lagyan natin ng varying load. Uniformly distributed. Then another varying load. So pare-parehas yung height, 10 kilonewton per meter. Then we'll add concentrated load here, another concentrated load here, and another here of 5 kilonewton each. The dimensions, five meters, 5 meters, 6 meters. Another one. Pagpraktisan nyo lang. Cantilever beam, with a ano ba to? Mas maganda. Varying load of 6 kilonewton per meter. Then there is a uniform load underneath it directed upward of 5 kilonewton per meter. And it is now sustaining a crane load of 15 kilonewton at its free end, on its free end. Okay? Dimension. This is 5 meters and another 5 meters. Point A, B, and C. A, B, C, and D. So on your own, pagpraktisan ninyo. If you have any questions while doing this problem, feel free to chat or email me so that I could discuss whatever is bothering you with this example problem. No. So pagpraktisan, then prepare for your quiz next March 24 to 30. So that next week we will now discuss frames. So para this week may upload ko na yung lecture regarding frames. Then next week discuss natin yung frames. Then on March 24 to 30, kailan ba yung susunod? Then March 24 to 30 will be your quiz involving beams and frames for statically determinate beams and frames. Naintindihan po? Nakuha yung problem na pagpapraktisan?
Yes, sir.
Nakuha Sigurado?
Yes, sir.